wanted to be one of those fancy guys, but they couldn't because one had too much, one didn't.
What did the other one have?
Too little.
Too little.
Too few
One too
electrons.
little, one too much.
And so what did they do?
They traded one.
Okay, so one gave up its electron to the other one, right?
Yes.
And then the result was a compound called sodium
Chloride.
right?
Sodium chloride.
That was the resulting compound that formed. Now, before we started talking about how metals and nonmetals come together, we were talking about how certain compounds are soluble, right? All of this came about before we started talking about these things. We were talking about solubility. Agreed?
Agreed.
Yes.
Okay. Is sodium chloride soluble?
Yes.
How do we know it's soluble?
Na.
Na, that's right, sodium, and also Cl, right? Chlorine is one that's generally soluble. Okay,
We put it in water.
here we go. Everybody grab a periodic table so you can have one. Pass it around to your friendlies.
David.
Okay? Oh, don't touch that.
What?
Okay, so
Dude.
we said from last chapter, from a while back,
Grab
right,
one and
last
pass it down
section,
to all your friends.
that sodium and chlorine or sodium chloride is soluble. Now, I'm going to teach you something different, something new. When you take a compound like this and put it into water, and it dissolves,
Pass
like
me
I
one.
told you, it separates. You guys remember that? How I told you how it separates? You guys remember that? When something, a compound that has a metal and a non-metal is placed into water, it separates. So when it dissolves,
Like water and
well, I don't know, like water and oil. That's not what I mean. I mean, it's soluble, right? So when a compound like this is soluble, it ends up, the two species separate. And sodium has a positive charge, and chlorine still has that extra electron that it takes when they're separate. Okay? Did you guys know that?
No.
Isn't that amazing?
Yes.
Now, why do they separate? Why do they separate?
Because they don't mix.
No, I don't mean like that.
Why would-
Remember, there's a container. Here's a container.
That's the way we write it.
Here's a container here. And here's a pile of salt that I have. I have it on a little tray, right? And I'm going to put this pile of salt into some water that's in this container. Remember this? This is called what?
Oh, solubility.
Solubility. We're trying to see whether or not this is soluble in that liquid, right? Okay? Now, what we're introducing is that we already talked about how we can tell if some things are soluble. For example, if sodium's in it, then it is always soluble, right? So here, what happens when this goes in, it dissolves. It looks like it disappears because you can't see it anymore. The powder dissolves in the water. It's soluble. And what's happening at a very small level that we can't see is that these species, the sodium and the chlorine, are separating like that. Are separating inside this solution. All right?
So if we put it under a microscope, we can see it, right?
Well, these things are all too small for even microscopes. All too small.
The atoms.
These are atoms, right? We don't have microscopes that can see atoms like this. We have other ways of knowing. So we have sodium with a positive charge and chlorine with a negative charge. Now, why does sodium have a positive charge again? Can somebody remind me of that?
Because it wants to be a noble gas.
Right. So sodium and chlorine met earlier. Remember that story yesterday?
Yeah.
Who wasn't here yesterday? Anybody was not here yesterday? Oh no, you guys missed the story? Do you remember the story?
Guys, my mom forgot to send me.
That's fine.
Seriously, I went.
So,
Chlorine.
sodium and chlorine met, and chlorine wanted to have an extra electron, and sodium said, hey, I have an extra electron that I want to get rid of, right?
Sodium
And
has
so
11.
they transferred electrons, and chlorine got that extra electron, and sodium lost it. And so sodium, when it loses an electron, ends up having extra protons, and that's a positive charge. Positive charge. Okay? So, this kind of compound has a special name. All right? This kind of species, a species that has a charge on it, has a special name. Do you know the name of the species? Name of what we call a species with a charge? Does anybody know? Any of you experts out there?
Positively awesome.
A species with a charge is called an ion. 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 I-O-N. Ion. Okay? I-O.
N.
Yes, fire the ion cannon. That's right. That's where they got that from. Makes no sense, but that's where they got it. Okay?
Perfect.
So, well, maybe ion is spelled differently in their language, or maybe it means something different. Yeah, maybe it's I-N. I-N. So, ion. So this is an ion, and this is an ion. Is this an ion right here?
No.
No. This is a compound made of what?
Iron.
And so if you have a compound made of ions, it's called an ionic compound. Ionic. I-O-N-I-C.
Dad,
Ironic.
is it ever possible that if sodium didn't want to trade with chlorine, what would happen? If it ended up not working out?
If sodium and chlorine wouldn't. If sodium and chlorine interact, they trade. That always
It's an
happens.
automatic.
Yep, automatic. Rules of nature, and you can't keep things apart. This is what happens. If you just have sodium by itself, all right? Do you think sodium is happy by itself?
No.
Why isn't sodium happy, Tom?
Because it only has 7. And it
So
wants
how
to
many
have
electrons?
8.
How many electrons does it have?
11.
11. It has 11, and it wants to have how many?
10.
10.
So it needs to
sodium
lose
is not happy.
He wants to be
Now there's another story out there. I told you this story yesterday about sodium met chlorine, right? It's a sad story, but in the end it was
He
kind of
has
happy,
11.
right? There's another story out there. You want to hear another story?
Wants 10.
Here's another story. Sodium, one day,
Has 17.
was so sad. Why is sodium
18.
so sad again?
Because it needs 1 less.
Electrons.
because he wants to be big like
Yes. But he couldn't find any chlorine to run into. But he did find somebody else.
Oh, who else could he meet?
Wasn't quite as attractive, but
Who wants to lose 1? 35. Bromine?
yeah, bromine would work too, but he couldn't find any bromine.
Iodine?
Nope, he found this person.
Helium.
Who's that?
Helium. H2O.
That's right, water. He found water. Now water said, oh, I understand your situation. I don't need any electrons or need any protons. I'm all happy, but I could help you out. So sodium said, okay. So what happens is sodium finds 2 friendly water molecules like this. See these friendly little water molecules? Finds 2 friendly water molecules, and it gives an electron to this oxygen here and makes it sodium hydroxide, like that. Sodium hydroxide. And there's an extra hydrogen that water lets go of. It combines with another extra hydrogen that some other water let go of and forms H2.
2 H's.
Hydrogen gas. So, sodium, if it ever can find some water molecules, will form this compound and hydrogen gas. Okay? And when this happens, you get an explosion. Ba-boom!
Seriously?
Yes. Because it's hot and the hydrogen gas explodes with oxygen gas to form water.
I found HG.
Hg is mercury. Yeah.
Wait, if you put salt and water.
Not salt. Not salt. Sodium metal.
Oh, the zinc. I found
Just
zinc.
sodium all by itself.
I found zinc.
Let's look at this compound then that's formed. Sodium hydroxide is what it's called. Can you guys say sodium hydroxide?
Sodium hydroxide.
Sodium hydroxide.
Sodium
I'm going to give you a
hydroxide.
hint about this compound. It is, well, first of all, do you think it's soluble in water? Do you think if you put it in
No.
water it would dissolve in water?
Actually, yes. Yes.
Some say no, some say yes.
It has Na.
Okay, it has Na, so the answer is yes. It does dissolve in water. And what does it form when it dissolves in water?
Na.
A sodium ion and a what?
OH ion.
That's right, a hydroxide ion. Hydroxide ion. Because this is what kind of a compound?
An ionic compound.
Ionic compound. Ionic compound, which is soluble. So when ionic compounds are soluble, they form, they separate into their ions. Okay? Ionic compounds that are soluble separate into their ions. Okay, how much time we got? 2 minutes. So, I'm going to show you another compound, and you tell me which ions it will separate into. Okay, here it is. And, well, let's not do Na. We've done Na so much. Feels picked on. KNO3. Is this compound soluble?
No.
How do we know it's not soluble?
Yes, it is. It is.
It is?
It has K. Potassium.
Potassium.
All right, potassium's in the first row, so that means that this compound what?
Is soluble.
Is soluble. So when it breaks down, what does it break down into? What does it break down into?
What do you
When
mean?
this compound is soluble, and if you put it into water, what does it separate into?
K.
K.
What does K want? One more, one less.
What does K want? Or what is trying to?
One less. K wants one less.
Yeah, K wants one less to become Aragon. Yeah, Aragon.
Argon.
So an NO wants
Well, NO3, we haven't talked about that. That's
nitrogen,
like the
oxygen.
OH thing. It's a polyatomic, many atom ion. We haven't talked about those yet.
Nitrogen, oxygen.
But what charge does the potassium end up with when it separates like this? It wanted to do what when it formed a compound? Lose an electron or gain
wants
an
it
electron?
wants to lose
It
one.
wants to lose.
Whoa.
When something loses a negative charged electron, then
Plus.
what does it get here? It gets a positive charge. So that means that NO3 releases with a
Negative charge.
negative charge.
It-
NO is a
Nitrogen,
is a
oxygen.
polyatomic, a many-atom ion that is formed when you combine nitrogen and three
Oxygen.
oxygens. And three oxygens, that's right.
Yeah, right here.
N and O form, this is called nitrate. This is the nitrate ion. Nitrate. There's lots of compounds that nitrogen and oxygen. What's that? 1 more minute. Here's the last one, okay? Here it is. Ready? Are you ready? Here we go. Here we go. R B 2 O. What do you think the name of this compound is?
RB2O.
Yep. What's his name? Very good. Rubidium oxide. This is rubidium oxide.
I just
Excellent.
found it right when you
So
said it.
what are, is it, it's a metal and a non-metal. Is it soluble in water, do you think?
No. No.
How do you know?
Because it's metal.
Okay. Sodium chloride and potassium nitrate contain metals and they were soluble in water. But is rubidium oxide soluble in water?
No.
How do we know?
Because it's a solid metal.
This is not a solid metal. It's rubidium and oxygen, right?
Oh.
Where is rubidium?
So yes, it is soluble.
Well, oxygen gas is sparingly soluble in water. Oxygen ions are actually not very soluble in water. But what about rubidium? What do we know about rubidium? Anything?
I don't see rubidium.
Ah, that's the problem. We have to find it. Let's find rubidium on the chart.
It's number 87.
Number 87?
What? Number 37.
37?
Yep.
Where's it at?
It's in the first row.
First row.
Oh, it's soluble.
It's soluble. It's soluble. How do we know it's soluble?
Because it's in the first row.
Because it's in the first row. Therefore,
It's a girl.
what kind of an ion is rubidium going to want to form?
Not in the first row.
What kind of ion
Yeah,
is
it is.
rubidium going to want to form?
Uh,
The lines are like this, not like this.
Hydrogen peroxide.
Have you guys noticed a trend? Sodium wanted to form a positive ion, right? Potassium wanted to form a positive ion. Everything in the first row wants to form a positive ion. And
'Cause
so
it wants
this
to lose
is
one.
Rubidium plus. And what does oxygen going to do? Oh.
oxygen wants to gain one, two,
It's a negative.
It wants to gain
two,
an electron. How many does it want to gain?
two.
2. So this is the charge. -2. Rubidium with the plus charge and oxygen with the -2. And that's why you need 2 rubidiums. So I should put a 2 here to say that we have 2 rubidiums for every oxygen ion. All right, very good. Thank you guys. We'll see you tomorrow, okay?
Oh, when you're missing